Hello, welcome to our online lesson. Um, so for today, you will need your pen, your pencil. I might even put that up. This is what you need. You're gonna need your pen or pencil. You need your book, and you'll need a calculator. All those things should be in there. You're also gonna need your worksheet actually too. So everyone, please come sit at a table. Geordie, Liv, Mariam. I bet you're probably sitting at the back of the classroom right now. If you could come find your seat at a table, because that's a good spot for working. All right. So everyone get their books open because we're gonna do, you can take this slow. Fun thing about this is because it's a video, you can pause it to make sure that you got all your notes down. But last lesson, what we did was prisms with triangular faces. There's an example at the front of your worksheet on how to do that. For those who were here last lesson, you will have all those examples in your book as well. So today we're going to work on examples, 3 examples to be specific, of prisms that have different shaped faces. Okay, only going to do 3 examples. Have all 3 examples copied into your book. These questions that I'm pulling out also are questions from your worksheet, so you can do them and practice them again if you want, but otherwise you don't have to. But pause the video, get your pen, book, and calc. Then we're going to get straight into it. Alrighty. So we have this prism here. This is a square or rectangular prism because we have a square face. A rectangular face. Now, one of the things that we were doing last time is that the very first step is we need to identify all the different types of faces. So I'm going to do our front and back face in blue because they are the same. And then I'm going to do the top and the bottom face in pink because they are the same. And then I'm going to do the left and the right side in green because they're the same as well. Now, just to show that they are the same, you can see that this side here is 8 feet. So that means this side here is 8 feet. So you can see that the front and the back are identical. You can also see then the left and the right have the same height and the same width. Here, this is the same width here as it is here. So the top and the bottom are also the same. So what that means is we're going to draw the faces that we're going to be calculating. So I'll draw them in here. We have one where our dimensions are, if we pull this, let's say this one's going to be our blue face, so the front and the back. This bit here would be what? We're looking at this bit and we need to see that if that's coming from over here, then our height will be 8. Now, I'll put in 8 feet, but beautiful. Then here, also, this is an American worksheet, so it's in feet, but it doesn't really matter. As long as that you're making sure that your units or whatever units you're using are squared in the end, that's totally fine. Now, our bottom is 4 feet. Beautiful. That's one. Now, let's do the green side. So I'll draw out our shape again, and I'll color it in green just so that you know which one we're talking about. Now, that is the side we're talking about is from here, these sides. So these faces here. We have 2 of them. We have the left face and the right face. Now, this section here, what would that be? What length would that be? Well, when we look back over here, we can see that that would be the bottom side, the longest side, which is 12 feet. And this here is the height from there up to here, which is also 8 feet. Oh, 8 feet. We have one more shape, which is, maybe I'll do that one down here. The top. I'll show you like this. All right. Now, we need to know, firstly, how long it is across here, and then how long it is across there. So the length, the longest side of this shape, we're looking at the top, this bit here. The longest side is from here to here. Now, if I'm looking at it there, that side has to be equal to this side, which is from here to here, which has to be equal to this side. So our 12 feet is the distance from there to there. So here, as well. All right, so I can put in 12 feet here. Now I need to figure out how long it is down the bottom. So we figured out how long it is down this way. Now we need to figure out how long it is there. We can see that that is 4 feet. Right, now how many, one of the things I like to do is I like to label how many of each I have. Now I know this is my front face, but I have a front and back. Two of these. I also have two of these. I also have two of these. Okay, now I put a 2 times there because when you go to total your surface area at the end, it's important to know how many you have because you've got to double or multiply by the amount of identical faces you have. So first things first, we're going to calculate the area of each of our individual shapes. Now, I'm going to do them all here, but I'm just going to color code it just so we understand which ones I'm talking about. Right now, I'm going to do the area of the blue one. So this one here. Okay, the area of this shape is equal to length times width, which is, in fact, you know what I might do? I might do this. Sorry for all of you who have already started copying down the notes frantically, which I know some of you probably have done. Anyway, I'll move this underneath it. All right, let's go in from here. All right, so back to business. Area is length times width. Now, here, our area is, that means 8 times 4. Now, it doesn't necessarily matter which you choose as length or which you choose as the width, because the same reason as 4 times 3 is 12, the same as 3 times 4 is 12. Multiplication is commutative, so it doesn't matter which order you do it. But if you want, you can stick to one and just roll with it there. But I'm going to say my length will be this side. This will be my eraser. This will be my length, and this can be my width. So 8 fours are 32. So our area is 32 feet squared. Now we'll move on to our next one. This area, because it's a square, again our formula is length times width, which is equal to 8 times 12. 8 length, 8 times 12. And 8 times 12 is 96, maybe? Yes. See, this is why sometimes it's good to rote learn things, because, I thought I had that, and I did have it. All right, next one. So here, same again. Area is equal to, it is a rectangle, so the area of a rectangle is length times width. Our length is 12, our width is 4. So 12 fours are 48 feet squared. There's the units. All right, now pause this if you want, just while you copy all that down. Then we're going to move into this. Here, the total surface area is equal to the addition of all of our individual surface areas. But remember, we have 2 times 32 because, remember, I'll highlight it. This comes from here because we have 2 of them, right? Plus 2 times 96 because remember, we have 2 of them. Plus 2 times 48. Just so that we're all aware where they're coming from. We have 2 and we have now 2. Beautiful. So 2 times 32 is 64, plus 2 times 96 is 100, 200, no, 192, plus 2 times 48 is 96. Is equal to the addition of these, 96 plus 102 plus 64 is equal to 352 feet squared. Beautiful. First one done. All right. This is a rectangular prism. If you want, you can label it rectangular prism. All right. We'll move on to our next one. This here. Now, what type of prism do we think this is going to be? Okay. Generally, also, our prisms, the naming convention is by the face that is not a rectangle. Note that all of our, what would you say, um, length faces or the is a rectangle because this is almost just like a rectangle that's been slanted, right? That's still a rectangle. However, this face here, face that is, the cross-sectional face, which is the cross-section means, right? If I sliced this straight down the middle through here and was to take a look at it, and cut it off, it would still look like that. It doesn't matter where you cut it, the cross section looks like that. So, what type of shape is this? If you guys have a look at your notes that you've taken in your books, you should be able to identify it. 10 points to whoever says it first. I'm going to guess maybe Eric. Maybe Eric said it first. Could have been Luca. Could have been any of you. But we're going to go into it. This fact check is a parallelogram because these here run parallel and these here run parallel, but it's not a rectangle because it is slanted. These internal angles are not 90 degrees, right? So it can't be a rectangle. Now, how do you find the area of a parallelogram? Well, actually, first, step back. We need to figure out, if we're going to calculate the total surface area, let's figure out how many identical faces we have. We'll go blue again to highlight that we have this front and this back. So we know these two are identical. How many other identical pairs do you think we'd have? Two. So we have this one here. Oh, yellow's not the best color. Let's go green. We have this side here, which is identical to the left side as well. Right? And then we have the top and the bottom again. Go with that, do that in pink too. Beautiful. All right. So just had to make sure that the microphone was on. Otherwise, that would have been like 20 minutes of wasted. Would have had to redo it. It would have been awful. But it was on. So we're all good. Okay. Now, let's draw our things. We have three different faces here. We have our parallelogram. Let's shade this in blue. How many do we have? Well, we have the front and the back. So we have two of them. We also have our long side, which is a rectangle, which is green. And then we have our top face, which is pink. We also have two of both of these. Now, you can fact check. We have six faces. 1, 2, 3, 4, 5, 6. 2 plus 2 is 4 plus 2 is 6. So we have all the faces accounted for. Now, let's put in our dimensions. Firstly, we know that this here is 7 feet. Now, have a look. What this says is interesting, right? This is the 8 feet that this is talking about. It's not actually the length of this side, but the perpendicular height from the top of the shape to the bottom of the shape. So that there is 8 feet. Okay, now we'll leave that there for now and we'll move into our next one too. Okay, so let's put in our values. We can see this rectangle, the green rectangle, has the dimensions 9 feet and 12 feet. So put that in there. We know that our long side is going to be 12 and our short side is going to be 9. Let's have a look at our pink side. Look at the bottom as well. Okay, here is 12 feet, here is 7 feet. So we have 7 feet here, 12 feet here. All right, if you need a moment to copy that in, get it all nice and neat. I'm sure some of you are probably using rulers, but you can pause it and do that. I'm going to move into it. Okay, first things first, we're going to calculate the area of this shape here, the area of a parallelogram. All right, so the area of a parallelogram in your books, what is the the formula for that? You should hopefully have base times height. Now, B is base. Base. The base of our shape is here. This height is not talking about our length. It is talking about the perpendicular height. So this is our height, which is 8 feet. All right. So our base is 7 and our height is 8. So the area is 7 times 8, which is 7 eighths are 56, I think. Surely. Fact check myself. Yeah. So 56 feet squared. All right, moving on. Again, we have our rectangles. Now, prisms love rectangles because in all prisms, you're always going to have a combination of different rectangles that make up the sides of the prism. And the faces, the front and back of the prism, are always going to be a variety of different shapes, but they will be two identical shapes. But you could have triangles, you could have parallelograms, you could have trapeziums, you could have other rectangles. But in prisms, you are always going to be a certain is that you're always going to be calculating the area of prisms, of rectangles. So the area formula is length times width. Now, call this our length and call this our width. So we have 9 times 12. And 9 times 12 is 196, 98, 9 times 12, 108, 108 feet squared. All right. So finally, we have our last rectangle. Our area for rectangle again is length times width. Okay, this is our length, this is our width, so we're going to have 12 times 7. 12 times 7 is 72. I just want to make sure. No, 12 times 7, 84. 12 times 5 is 6. Anyway, so 84 feet squared. Now, let's total it all, okay? Remember, we have 2 of each, so our total is equal to 2 times 56 plus 2 times 108 plus not just 84, but 2 times 84. All right. Now remember, these come from here. The fact that we have 2 of those shapes in our prism, right? We have 2 of them. So 2 times 56 is 112, plus 2 times 108 is 216, plus 2 times 84 is 168. Adding all those together, (496) feet squared. There's your answer. And this is called a parallel prism because it's from a parallelogram. Here, question E. Also, there you go. Here's your, if you need to copy this down, you can pause it here. It's a nice place to copy it, and then we can move into the next little section. Okay. All right. So, first things first, let's name the prism. So, naming the prism, again, we're going to be looking at this front face. Now, what shape is that front face? This kind of one confuses a lot of people, but it is a trapezium. So this is called a trapezoidal prism. Trapezoidal prism. Trapezoid, that word trapezoidal always makes me think of Zoidberg. I don't know if you guys ever watched Futurama, but anyway. So normally when you think of a trapezium, you kind of think of a shape that looks like this, right? But a trapezium can take two forms. It can either look like that, or it can look like this. It is just where one side is longer than the other side, right? For instance, this is here. But, these two, yeah, anyway, the way that we calculate the formula for a trapezium is important. Okay, it's a bit of a more of a complicated formula. We should have it in our books as well. The first step to calculating the surface area of any prism is identify how many identical shapes we have. Now, this one's a little bit different to any other one that we've done so far because we have here front and back, which are the same. Now, have a look at this. We have four sides, but as you can see, the top is different to the bottom. So I'll put those in different colors. And then the back or the side is different to this side. So when we count how many different types of faces we have the front and back, which are the same, so we have one. Then we have another side, so we have two, three, four, five. So we have five different faces. So that means we have five different calculations. Okay. First things first, let's draw it out. We have two of the front and back pieces. Right? And this is dimensions 8 millimeters and 8 millimeters. And the top is 2 millimeters. All right. Then we have, let's do our orange side, this side here, which is 10 by 10, which should actually look more like a square, but it doesn't. But if you have a rectangle that's 10 by 10, it's a rectangle and it's a square. Because remember, a square is a rectangle, but a rectangle isn't always a square. Anyway, here we also have this one, which is 2 by, let's have a look. We know it's 2 meters across. We need to figure out how long it is this way. We can see that there's no length on the other side, but if we keep following down, we get a length here for how long that shape is. So we know that it's 10 meters. So it's 2 mils by 10 mils. All right. So we need to have two more sides. We've got the bottom and the side. So let's do the left side first, the pink side. Have a quick look at it. We know it's going to be 8 mils down. And then across, we just figured out that this here was 10 mils. So it's going to be 8 by And then our final one, I might do over here, which is blue. And we can see that our long side is 10 millimeters, our short side is 8 millimeters. Beautiful. All right, so let's calculate some areas. First things first, we have two of our trapezoids. Now, if you look in your notes, I want you to see if you can find the area formula for this first. Pause the video, take your time. Let's see how you go. See who gets it right. All right, so the area is equal to half, in brackets, A plus B times H. Now, I'll put them in here. Our A, B, H. So A and B are the two sides running parallel to each other, and H is the height of it. So we have half, and our A is 2, our B is 8, and our height is also 8. So half of 2 plus 8. So the way that you do that is you do the in here first. 2 plus 8 is 10. Half of 10 is 5. So 5 times H. Oh, and sorry, this height here is 8. So it's 5 times 8, which is 40. Now, if you wanted, you could have put the 8 in here straight away. Okay, so it could have been half outside of 2 plus 8 times 8. I just put it in a little bit late. Anyway, we found that. So it's 40 millimeters squared. Here, our area for a rectangle is equal to length times width, which is equal to 10 times 10, which is equal to 100 millimeters squared. Here, our area is equal to, again, length times width, which is 2 times 10, which is 20 millimeters squared. Again, rectangular formula. By now, we should be getting the hang of it. Length times width, which is 8 times 10, which is 80. And then over here, we have our final rectangle, which is area. It's equal to length times width, which is equal to 8 times 10, which is equal to 80 millimeters. Would you look at that? This face is the same as this face. I just did not notice it straight away because generally opposite faces are equal, and because they weren't opposite to each other, I just assumed they weren't going to be, even though they are. Anyway, let's find our total. So our total is equal to, now remember, we have two of these faces. We only have one of everything else. So we're going to have, well, 2 times 40 plus 100. Now we're not multiplying by 2 because we only have one of them. Plus 20 plus 80 plus 80. So 2 times 40 is 80 plus 280, 360 millimeters squared. All right. Now I just got this as 280 in case you wanted to know. Here and here is 100 plus 100 is 200 plus 80 is 280. 80 plus 280 is 360. And there is our final example of the day. Good work, everybody. I hope that all of you copied in some fantastic notes. I will be looking at those notes next lesson. For now, just go on with that worksheet. Do as many questions as you can, and then we'll see. Maybe I'll bring in a prize for the person who completes the most questions. Hey, all right. Good work, everyone. Proud of you. See you on Thursday. Yep, see you Thursday.